Here's our other two examples on our limiting reactant notes for limiting and excess calculations. So the first thing that I'm going to do here is I'm going to read my problem, and it says 6 moles of nitrogen are mixed with 12 moles of oxygen. How many moles of ammonia can be made? So if I have two values in my problem, I know I need to do two separate t-charts. So I'm going to set up my t-chart here so I know that if I start with 6 moles of nitrogen here, moles of nitrogen is the unit that goes on the bottom. And then you ask yourself, can I go from moles of nitrogen to what my problem is asking me for, which is moles of ammonia? So I can do that. I'm in Mole City or Moleville. So Mole City, my map to Mole City is the balanced chemical formula. So I know that I have 2 moles of ammonia, and I know that I have 1 mole of nitrogen. So there I look, I'm in the unit. When I cross that out, I'm in the unit that my problem asks me for. So then I can do my calculation, and I know that 6 moles of nitrogen will create 12 moles of ammonia. So in the other question, the other t-chart I need to do is 12 moles of hydrogen. So 12 moles of hydrogen will start in my upper left-hand corner of my t-chart. Moles of hydrogen I know can go to moles of ammonia. I'm in Mole City. My map to Mole City is the balanced chemical formula. So I know that I have 3 moles of hydrogen and 2 moles of ammonia. So when I do that math, I know I can make 8 moles of ammonia. Thus, I can only make 8 moles of ammonia. So my reactant that is limiting is that, so I'm going to circle that value, right? So my reactant that is limiting is the hydrogen because it only made 8 moles of ammonia. My reactant that is in excess then is the nitrogen. So now, how many moles do I need? How many moles of excess reactant do I have or do I need? So I'm going to take the circled answer, I'm going to do stoichiometry back to the units of the excess reactant. So I'm going to take 8 moles of ammonia, and I need to go back to my units of my excess reactant. So the chemical reactant that is in excess is nitrogen. I'm going to go back to the units that I started with. So I started with moles of nitrogen. So that's a good way to remember that. I'm going to go back to the units that I started with. So I know that I have moles of ammonia down here, and I want to go to moles of nitrogen, and I know I can go mole to mole here because this is Mole City, and my map to Mole City is the balanced chemical formula. So I know that I have 2 moles of ammonia and 1 mole of nitrogen. So in order to make 8 moles of ammonia, I would need 4 moles of nitrogen. Okay, so 4 moles of nitrogen are needed or used to make the 8 moles of ammonia, which means now I can calculate how much I have left over. So to find my excess, I'm going to calculate what I started with minus what I used to give me my excess. So I started with 6 moles of nitrogen, and I get that right from the problem right here. And I used 4 moles of nitrogen, which is what I calculated right here. So I know I have 2 moles of nitrogen left over. The next example here is the question asks if you have 20 grams of nitrogen gas and 10 grams of hydrogen gas, how many grams of ammonia can you actually make? So again, I have 2 values in my problem, so I know I need to do 2 different t-charts. So now I'm going to go 20 grams of nitrogen, and I know if I have grams of nitrogen there, I need grams of nitrogen on the bottom. And then my problem is asking me to get to grams of ammonia. So you ask yourself, can I go from grams of nitrogen to grams of ammonia? And hopefully you're thinking, nope, there's never a gram to gram, but you can go from grams of nitrogen to moles of nitrogen. Anytime I have moles over grams, I know I have 1 mole, and I have the molar mass, or formula weight, of nitrogen. So nitrogen is a diatomic molecule. When you look on the periodic table, nitrogen, you're going to multiply that mass by 2, so you will get 28 grams instead of 14. So then you look at your final value or unit that you're in, which is moles of nitrogen now, and you know you need to continue because the problem asks you to get to grams of ammonia. So you're going to continue your t-chart, and you know moles of nitrogen needs to go on the bottom. And then you ask yourself, can I go from moles of nitrogen to grams of ammonia? Anytime you go moles to grams, your chemicals here, compounds or elements, need to match. So you cannot go from moles of nitrogen to grams of ammonia. So now you know you need to go through your favorite city in this unit, which is Mole City. So Mole City, the map to Mole City is the balanced chemical formula. So you know that you have 1 mole of nitrogen and 2 moles of ammonia, and you're getting that number right up here from your map or the balanced chemical formula. So now your units are in moles of ammonia, but you know you need to continue because it asks you for grams of ammonia. So you know that moles of ammonia needs to go on the bottom, and now you ask yourself, can I go from moles of ammonia to grams of ammonia, and I can because anytime you go moles to grams, the compounds or elements here have to match. And my values, anytime I go moles to grams, I know that I have 1 mole, and I know I have the molar mass or formula weight of ammonia, which is 17 grams. So when I cross everything out and I do my math, I know that I can make 24 grams of ammonia. So then the next one I need to do 2 T-charts here. So I'm going to start with 10 grams of hydrogen gas. And I know that grams of hydrogen goes on the bottom. And I know I can't go to grams of ammonia right away, so I'm going to need to go to moles of hydrogen. Anytime I have moles over grams, I know I have 1 mole. And I have the molar mass of hydrogen, which is 2, because it's a diatomic. So I've got to multiply 1 by 2 to get my 2. I know I need to continue my T-chart because moles of hydrogen is the unit that I'm in, and I need to get to grams of ammonia. So moles of hydrogen will go on the bottom, and hopefully you're thinking to yourself, I know I'm going to go through mole city, and my map to mole city is the balanced chemical formula. So I know up here I'm going to use these values here, and I know that I have 3 moles of hydrogen to 2 moles of ammonia. I know I'm not done because my units are in moles of ammonia, and my problem asks me for grams of ammonia. So I'm going to continue my T-chart. I'm going to put moles of ammonia on the bottom, and I know I can go to grams of ammonia. 1 mole to 17 grams, just like over here, and I know I'm going to get 56.6 grams of ammonia. So based on looking at this, I know that my limiting reactant is nitrogen, and my excess reactant is hydrogen. So I'm going to circle my smallest, and I'm going to do stoichiometry back to my units of my excess reactant. So I'm going to take grams of ammonia here, and I'm going to do stoichiometry back to the units of my excess reactant, and it's the units that I started with in the problem. So I need to go back to grams of hydrogen. So I know grams of ammonia need to go on the bottom, and I'm going to go to moles of ammonia, and then I know that I have a 1 to 17 ratio there, and I know moles of ammonia needs to go to moles of hydrogen. I'm in mole city, so I know it's 3 to 2, and then I know moles of hydrogen to grams of hydrogen, so I know it's a 1 to 2 there. So again, I'm going to take my value that I circled, and I'm going to go back to the units of my excess reactant, because here I am trying to figure out how many grams of hydrogen does it take to make 24 grams of ammonia. How many grams of hydrogen does it take to make 24 grams of ammonia? So then I'm going to do my calculations, and I know it takes 4.2 grams of hydrogen to make 24 grams of ammonia. And then my last step is to figure out how much I have left over. So then I'm going to start my calculation with what I started with, and I'm going to subtract what I used or what I needed to get my extra. So I started with 10 grams of hydrogen. I used 4.2 grams of hydrogen, and I get that calculation from this step right here. So I know that when I do my subtraction, I get 5.8 grams of hydrogen. All right, there's your example problems for limiting and excess. Thanks.